have the list of people that have to get money into the school?
Do I do
Oh,
do
that
what
was due
now?
yesterday.
Yeah, do you have the list of people that owe money to the school?
You talking about for their tuition?
Yeah, because they got me
Yeah,
owing
I had that.
$1,600, and I don't know any.
I don't think you were on it. Um,
Did they send you? They extended it until Sunday, the 12th, but they got me owing $1,600, and that can't be right.
Yeah,
I
that's
lost some money
Yeah.
Same
for
here.
that doesn't sound right.
I'll ask
I thought mine
my
was crazy.
I'll ask Denise if she's
Yeah,
got
mine
a
said
copy of that.
because they said I owed $1,600, but I get like $6,000, so there's no way I owe them any money.
Yeah, I'm not sure. You wasn't on the main list though, so you must have yours all right.
So I got to call them and see why they got me listed as for that much.
Yeah, maybe call up to the school and see if something is messed up.
Mhm. Yeah, that's what I would do, y'all. Cause
That's what I'm gonna do.
You're not only in this class though; you have another class. I thought.
Yeah,
Aren't you a couple?
I've got 4 classes. The
Yeah.
first, second, and
So maybe it is right because even my one class was like 900 something. So it could be some. I know it's crazy. School's a scam. No offense, Mr. Eugene.
second. Oh, it is a big one.
mhm.
But I'm doing it for my own well-being.
It goes up every year. It seems to raise. The more money I get, the more money they take.
Alrighty, y'all. So we're getting into 2.4 today, and it deals with what we call the algebra of functions. So there's 4 operations we're going to look at on this. So the first one would be f plus g of x. So f plus g of x is just 2 functions being added, so it would be f of x plus g of x. And remember, when you're adding 2 functions, the only thing you can do is add like terms. Once you've added like terms, you're pretty much done. Second operation, we can look at subtraction. So f minus g of x will be my f of x minus g of x. So when you're subtracting, the thing you got to watch out, because I'm going to be putting these functions inside parentheses. So the things you got to watch out on these, you want to distribute the subtraction. After you distribute the subtraction, then you're going to add like terms. So if you was in the foundations, that's why we gave you problems where you had subtraction followed by parentheses, because we wanted y'all to distribute through those, okay? So that's what adding, subtracting. Next would be multiplication. So f times g of x will just equal f of x times g of x. So now you're dealing with multiplication. So when you're multiplying, you got to watch out for those exponent rules, okay? And this will be either distribution or foiling that you do when you're doing your multiplying. And then let's see, the last one we'll look at is f divided by g of x, which will equal my f of x divided by r g of x. Now, the one thing you got to watch out for on division, remember that the g of x on the bottom cannot ever equal 0. Because if g of x equals 0, that's going to make it undefined. Okay? So I tell you, the best thing I do to these when I first set up my problems I keep everything in parentheses, and then I work from there. So y'all watch this. We're going to be given f of x equals x squared plus 3. G of x is going to equal x plus 2. They want us to find f plus g of x. So when they give us a problem like this, they're not giving me no numbers to put into it. So all I can do is add the like terms, okay? I'm not going to be able to simplify because I don't know any numbers for the x they're giving us. So what we want to do, we're going to find f plus g of x. And up here we said f plus g of x equals your f of x plus your g of x. So I usually start out putting parentheses for these functions. And I'm going to put my f of x in here. And f of x they gave us was the x squared plus 3. And then I'm adding that to my g of x, which they gave as a x plus 2. So since everything up here is positive, we can now drop these parentheses and have an x squared plus 3 plus an x plus 2. Okay, you would treat these like they had positive ones in front of them. And remember, a positive one is not going to change what's in your parentheses. So y'all, you're looking at that expression, x squared plus 3 plus x plus 2. The only thing we can do is add those like terms now. So if you notice, nothing will add to the x squared because there's no more x squareds here. So the x squared will come down. And I'm going to put mine in order. So next I'm going to put the x's. And I've only got the one x, so it'll come down. So remember, to add these x's together, they would have to have the same exponents. Now I do have like terms that are numbers sitting here. So since my 3 and 2 are both positive, I'm just going to add that, and 3 plus 2 will give us a 5. So now that we got an x squared plus the x plus 5, we cannot go any further, and that would be the final answer. You know, this ain't too bad. It's just adding, subtracting, and doing whatever they want us to, okay? They'll get trickier later when they start doing the domain stuff.
Mr. Eugene,
Mm-hmm.
high school taught us to put like an exponent of 1 if the x didn't have like an exponent,
Oh, yeah, you
and
can do
add
that.
that together.
Like you can put your exponent of 1s on these, but just remember, when you're putting them in MathLab, I don't think it likes y'all putting a 1 as an exponent.
Okay.
Because to the MathLab, if you put x to the 1, they consider that just an x.
Okay.
So we understand it's got those, you know, and it's sort of like you can put 1s in front of these too, right? So we had a lot of 1s in math. But yeah, when we start multiplying, I definitely treat them like they got those 1s, because when you're multiplying the variables, you got to add their exponents. So you always want to treat it like at least a 1 there, okay?
Okay.
All right, so here's one that looks like multiplication. They're given f of x is going to equal x squared plus 4. G of x equals x minus 1. We're going to find f times g of x. So sometimes they'll use the little dot for multiplication, and then sometimes they'll just put them letters right next to each other for multiplication. So what we're going to do is find f times g of x. That's going to equal my f of x times my g of x. So what I want to do is put my f of x in parentheses and my g of x. So my f of x they gave me was the x squared plus 4. So I'm going to put that in the first one. And then the g of x was an x minus 1. Now this is the place where you would probably want to treat that like you got a 1 by that exponent on that x. Because since I'm multiplying, I'm going to have to start adding these exponents. And I'm going to actually FOIL this one. Because I got 2 things times 2 things, right? So what I'd like to know, what am I going to get when I multiply that x squared times that x? Oh, a lot of silence.
Like,
So I think someone said what, a x to the third?
yeah. Well, is it not x cubed? I mean, I don't know.
So remember, x squared times x, add those exponents, and 2 plus 1 will give you 3 on that. Then you take that x squared times that negative 1, and that's just going to give you a negative x squared. So that variable didn't change because it didn't have another x over here to change the exponents. So that takes care of the x squared. Now we take the 4 and multiply by the x, and 4 times x is a positive 4x. And then finally, I'll take that 4 times negative 1, and that'll give me a negative 4. And notice I got an x3, an x squared, a 4x, and a negative 4. None of those are like terms, so final answer. So there's that foiling memory for you. All right, y'all, watch this. This has f of x is going to equal x squared minus 2. G of x is going to equal x plus 3. They want me to find g times g of an x. So they give you a whole lot of information up here, f of x and g of x, but all they want is g times g of x. So what we would do, we would have g times g of x is going to equal g of x times g of x. So really, they gave me this f of x stuff, and I'm not even using it on this problem. They're trying to throw curveballs at you, okay? So g of x is when I say x plus 3 times g of x, which is x plus 3. So they're just trying to throw you a curveball, but you got to look at what they're wanting you to multiply when you set them up, okay? And if you notice, this is another FOIL problem. So I'm going to start distributing again. So what y'all going to get when you do an x times an x?
X squared.
And then we're going to take that x times that 3 and get us the, And then notice 3 times x is another 3x. And then at the end, I got what, a 3 times 3. That'll give us a 9. Now, this kind of FOILing should be similar to what y'all did in foundations. Y'all would have seen something like an x plus 3 squared. And they say, hey, write it twice in FOIL. So that's basically what happened in here. But y'all notice, this one will go one more step. And it's right there, right? In the middle, you got like terms. So you bring down your x squared. Now remember, here's the rule. When you add these variables, you do not change the letters. You cannot change variables when you add, and you can only change how many you got. So I got what, 3 and 3 is going to give me 6x, and then I'm going to bring down my 9. I tell you, a lot of people, when they add x's, they'll change them to x squareds. But remember, the only way to make an x squared up here was when we multiply an x times an x. So once you get past all the multiplying, you're not able to change what the letters look like, just how many you got. All right, y'all. So the next one, they're going to start throwing some numbers. So this one, they're saying let f of x equal negative 16x plus 4. G of x is going to equal x squared plus 18. So watch this. They want us to find f of negative 7 plus g of a negative 7. So this time they are giving me replacement numbers here, okay? So I know f of negative 7 plus g of negative 7 is going to equal my f plus my g. Now remember, they got a negative 7 here instead of an x. So when I put this f of x into these parentheses, I got to replace this x with that negative 7. So you're going to have negative 16 times x, which is negative 7, plus 4. So it still models the f of x, except now we got the negative 7 in for the x. And then the g of x also has a negative 7. So I'm going to replace that x squared with a negative 7 squared plus 18. All righty. What kills people on this one is they don't put these negative numbers in parentheses when they square them, and it throws off the sign. So notice, order of operations, the first thing we got to do is work inside of each parentheses. And I do have work I can do inside of these. This one I could multiply to negative 16 times the negative 7. So let's see, negative 16 times the negative 7. That's what, a positive 112 plus 4. Over here, I'm going to square that negative 7. And negative 7 times negative 7 is a positive 49 plus my 18. Now notice, I've only got one thing I can do in each of these parentheses. So after I add in each of them, I can drop the parentheses. So I can add the 112 plus 4 will give me 116. Plus over here, the 49 and 18, I think is what, 67. And now I can finally add these two numbers together, 116 plus 67, and that's going to give us 183, final answer. See, all these are not bad. You just got to keep up with signs in here, okay? Like I said, a lot of people will come in here and go, oh, negative 7, and they square it like that, and they get a negative 49. Well, a negative times a negative ain't going to make that a negative 49. So you got to be careful. Although the calculator helps us, negative numbers, we got to put in parentheses, okay? All right, so the next one's going to have numbers also. They're giving me f of x is going to equal negative 16x plus 19. G of x is going to equal x squared plus 18. I'm going to find f of negative 6 minus g of a negative 6. Alrighty, so I know f of negative 6 minus g of negative 6 is going to equal my f minus my g. So remember, I'm putting negative 6's in for their x's. So for f, we'll have negative 16 times that negative 6 plus 19. For the g, I'll have a negative 6 squared plus 18. And then y'all do it like I did up here. I got a few steps I can do inside each parentheses. So I'm going to be keeping them for this step. Woo, a negative 16 times a negative 6 is going to give me a positive 96 plus that 19. Inside these parentheses, negative 6 times negative 6 is 36 plus the 18. So remember, this is going back to your order of operations, the PEMDAS stuff. And when you have parentheses first, it means you got to work everything in them parentheses before you can come outside of them. Alrighty, so now I can add 96 plus 19 and get 115. And since it's a single number, I no longer need those parentheses. 36 plus 18 is 54. And y'all, 115 minus the 54 is going to give us 61. Final answer. Okay, so they're not too bad. You just got to sort of keep up with what numbers you're putting into those and following them rules of exponents. All right, so let me try this one. I got f of x is going to equal negative 17x plus 13. G of x is going to equal x squared plus 14. We're going to find f of 6 divided by g of 6. So f of 6 divided by g of 6 is going to equal my f divided by my g. And remember, for the f, I'm going to put a 6 in for that x, and then on the g, I'm going to put a 6 in for that x, since they're giving me 6's for both of them. So on top will be negative 17 times 6 plus 13. On the bottom will be a 6 squared plus 14. Now, if you do this one on the calculator, I would definitely put all these parentheses around the top and the bottom, or it won't give you the right answer on that, okay? All right, let's see what I get on top. Negative 17 times 6 is going to be a negative 102 plus my 13. On the bottom, 6 squared is 36 plus 14. All right, so I'm still going to work on the top. I'm going to add that negative 102 plus 13. And that's going to give us a negative 89 on top. On the bottom, 36 plus 14, what's that, 40, 50? And then at that point, Let's see if that'll simplify. Negative 89 divided by 50. It's going to give me a decimal, but I'm going to turn it back into a fraction by hitting math and enter twice. And notice it gave me the same fraction, which means that's the final answer. Okay, so not too bad. You just want to, when you get done, see if those fractions are reduced or not. If they don't, move on and be done with it. All right, so I'm going to switch papers now because I got a longer one coming. Oh, where'd it go? All right, so this one says find the sum difference product or quotient. So this one wants me to find f minus g of x when f of x equals 4x minus 3 and g of x equals 7x minus 6. And y'all, I'll tell you what, this problem gives people more fits than anything. So let's see what we got. We got f minus g of x is going to equal my f of x minus my g of x. So they're giving me f of x is 4x minus 3. They're giving me g of x is a 7x minus 6. Now, I cannot do anything inside these parentheses. Cannot do anything inside those parentheses because they didn't give me no numbers to put in for these x's. So what I've got to do is now drop the parentheses. So if you have parentheses that have nothing in front of them, we treat it like a 1. And when you distribute a 1, it's not changing what these numbers look like. This will still be what? A 4x minus 3. What you got to worry about is what's following after this subtraction. So you treat that like a negative 1 here, and you distribute it. So a negative times a positive 7x will make that a negative 7x. But y'all, how about this? That negative times that negative 6 is going to make that one a positive 6. So subtraction will change the signs of everything inside the parentheses that follows. That was a positive 7 become negative. That was a negative 6 became positive. Now, once we've gotten rid of the parentheses, we can now add like terms. So x's will add together. So the question is, what's a 4x added to a negative 7x going to give me? That's going to give me a negative 3x. But then you got numbers that are like terms. That negative 3 will add to that 6. So that's basically 6 minus 3, which will be a positive 3. So notice when you add, since this larger variable was negative, the variable stayed negative. And then since this larger number was positive, the number stayed positive, okay? All right, so that was it on that. And so next one, they're giving us f of x Oh, and I'll write X right there so y'all know that's a new one starting. Where'd I go? F of X is negative 2X plus 2. G of X is going to equal X squared minus 3. They want me to find G minus F of X. All right, so let me pull that down a little. All right, so G minus F of X. Now notice it's going to equal the G minus the F. They gave me the G first, so they're trying to throw a little curveball at us. So for the G, we'll bring down the X squared minus 3. And then over here for my F is a negative 2X plus 2. So they're really wanting y'all to learn about distributing these negatives. That's why they're giving us so many of these with subtraction. So the first parenthesis, since there's nothing in front of it, we drop the parentheses, and I get an X squared minus 3. Now you're going to distribute. So that negative times that negative 2X is going to make that a positive 2X. Then that negative times that positive 2 is going to make that a negative 2. So once again, that went from negative to positive, positive to negative. That's the power of a negative, okay? All right, let's see. Now we're going to add like terms, and the only thing that's going to add together are these numbers. So let me bring down that X squared. Where did my X's go? I had positive 2X. And a negative 3 plus a negative 2 is a negative 5. So remember, when you add like signs, add the numbers and keep that sign, okay? Whoop. Let me do one thing real quick, y'all. Okay. All right, so going on. So do y'all like this better than the graphing?
Yes.
Absolutely.
Mm-hmm.
No.
All right, let's see. F of X, y'all, is going to equal X squared minus 8. G of X.
You're not on the board, sir.
Oh, am I not on my share?
Nope.
Oh, let me go. All right, so let me share back. All right, y'all hearing me?
You're too high.
Oh, you mean like that?
Yeah,
Okay, we're good now, right? All right, now watch this. F of X was X squared minus 8. G of X is 2 minus X. Y'all, they want me to find F times G of an A. So, F times G of A. So here we go. F times G of A is going to equal my F of A times my G of A. So when they give me an A in here, I got to replace these X's with the A. So this first one, instead of X squared minus 8, will be A squared minus 8. And then this one, instead of being 2 minus X, that's going to be 2 minus the A. Now, we've got the a's replaced like we needed to. So now we're going to multiply this by FOIL again. So watch this. This a squared will multiply by the 2. And 2 times a squared is 2a squared. Now be careful right here because you got an a squared times a negative a. That's automatically going to be a negative. And then the a squared, remember, has a 1 by this a. So 2 plus 1 gives you a to the third. Then let's distribute the 8. Negative 8 times 2 is negative 16. And then that negative 8 times a negative a. Negative times negative is a positive 8a. And let's see. I don't see any like terms. So the only thing I would do would just rearrange it and get the exponents from high to low. So the highest exponent is 3. So I'm going to put my negative a to the third first. Then I'll bring down my positive 2a squared. Let's see, what's next? My positive 8a. And then my minus 16. So I just rearranged them here. I don't think you have to in the math lab. I just get used to it because later in life you will have to start putting stuff in that kind of order. All right, here's a good one. For the functions, determine the domain of the sum, difference, and products. And they're giving me f of x is going to equal x squared. G of x is going to equal 3x minus 10. So this one is basically 3 problems because I got to find the domain of the sum of these products, the sum of these functions, the difference of the functions, and the products, okay? So let's play with the sum first. So I'm going to find a domain of the sum. Well, the sum would be what? My f of x plus my g of x, which is an x squared and then a 3x minus 10. So remember, on a domain, there was only 2 things I'm worried about. One was fractions, the other one was the radicals. There are no fractions here. So since there are no fractions, this is going to be x such that x is a real number. Okay, there's nothing that'll make this have a 0 in the bottom of a fraction because I don't even have a fraction here, okay? So the domain of the difference the difference would be the f minus the g, which would be the x squared minus the 3x minus 10. Y'all, I don't see anything in that one that looks like a fraction. There's no fractions. There's no radicals to worry about. So this one would be x such that x is a real number. I can put any numbers I want to into this and it will work out, okay? All right, then I got the domain of the product. Well, the product will be the f times the g, which will be the x squared times the 3x minus 10. So these will all multiply. Once again, I see no fractions. I see no radicals. So since I have no fractions to worry about, this will be x such that x is a real number. Now, I'm going to show y'all something. Notice, this one did not ask for the domain of the quotient, but let me show you what would happen on that. If you had the quotient, so the domain of the quotient would be f of x divided by the g of x, which will be the x squared, and then the g of x would be the 3x minus 10. Had they asked for the domain of the quotient, remember, I would have had to took the bottom and did 3x minus 10 cannot equal 0, and I would have had to solve that. Okay? So I'm just going to give you extra bonus on this and show you what we would have done if it was a quotient. You would have solved that by adding 10, and then I divided both sides by 3, so that x could not equal 10/3. So had they asked for the quotient, it would have been x such that x is a real number and x cannot equal 10/3. So I only do this to show y'all that every one of these don't necessarily have to be x. X is a real number. It depends on what operation you're doing and how you got it set up. But I hope this showed you why I had to kick out 10/3 from my domain, because if you put a 10/3 in for the x, it makes the bottom equal 0, which makes it undefined. And you cannot plot numbers that are undefined, okay? All right, so we got a doozy coming up. So this ought to take me into break after this one. All right, y'all, this one has f of x equals 1 over x minus 4. This one has g of x equals 6x to the 3rd.
Can you move the paper again, sir?
Oh, man, I do that every time.
Thank you.
I do that every time, y'all. My bad. I got to get back into the sink of doing this. All right, so I'm going to find the domain of the sum, difference, and product. So, oh, it's already 8:50. So what I'm going to do, we'll do our 10-minute break, and then we'll come back and do this one because it'll take us a little bit. But it's sort of like that last problem. But this is going to be trickier, so let's do a 10-minute break. I'm going to pause my video. So we'll pause that and back to my screen. All right, so this is going to be a fun problem here, y'all. So first, I'm going to find the domain of the sum. Well, the sum will be my f of x, which is 1 over x minus 4, added to my g of x, which is 6x to the 3rd. So now we do have something that's bothering us, and it's this fraction here. So I know from my fraction that that x minus 4 cannot equal 0. So we'll solve that by adding 4 to both sides, so that this one tells me x cannot equal a positive 4. Because if I put a 4 into that, I get a 0, and 1 divided by 0 is undefined. So there's no way I could add that together if this bottom number was a 4. So our domain will be x such that x is a real number and x cannot equal positive 4. Okay, so when you have fractions, you got to take care of numbers that'll make those fractions undefined. So then we go into the domain of the difference. So the difference will be the f of x, which is 1 over x minus 4, minus the g of x, which is 6x to the third. Well, guess what? Once again, I have a fraction here. So I know that that bottom, x minus 4, cannot equal 0. And I'm going to get the same number, right? So I'm going to add, and I get x cannot equal a positive 4 again. So whether it's adding or subtracting, that x on the bottom cannot equal a 4. So here we go. X such that x is real and x cannot equal 4. All right, and for the product, that'll be multiplying, right? So the domain of the product, for the domain of the product will be the f of x, which is 1 over x minus 4, times my g, which is 6x to the third. So I'm looking at this, and once again, I've got a fraction, which means that x minus 4 cannot equal 0. So y'all once again solve that by adding 4, and we get x cannot equal a positive 4. So for the third time, x such that x is real and x cannot equal 4. And you'll notice the sum, the difference, and the product are very similar on their domains. The only one that might be different that they didn't give us would be for the quotient on that one, okay? Now, this last question I'm about to do does do the quotient, okay? So let me turn this. So this one says, find the domain of f divided by g. F of x is going to equal 4x minus 9. G of x is going to equal 9x minus 90. Alrighty, so f divided by g is going to equal my f, which is 4x minus 9, divided by my g, which is the 9x minus 90. So for this one, we're definitely worried because we have a fraction here. And since I got a fraction, I'm going to have to take that bottom, which is 9x minus 90, and set it not equal to 0. Remember, we don't care about the top. The top can be a 0. The bottom is the only one that cannot be the 0, okay? So let's solve this. We're going to what? Add 90. So I get 9x cannot equal 90. And then we divide by 9 to make that a 1x. And it cannot equal a positive 10. Because if I put a 10 in here, 9 times 10 is 90. 90 minus 90 gives me 0. So that domain would be x such that x is a real number and x cannot equal positive 10. All right, y'all, so that was 2.4. So mainly a bunch of algebra type stuff, okay? No graphing in this section. All right, so we're going to get a start on 9.1 for sure. So let me move to that. Nine point one deals with what we call the composition of functions. Okay. So let me show you some new symbolism. We got f of g of x. Now, that's not a 0. That's almost like a degree symbol. But this is what we call the composition operator. So composition operator. Now, all this means f of g of x is f of g of x. Which means you start with the g of x function, you work it, when you're done, you put that answer into the f function, okay? So on this one, we put the g of x into the f of x. Oh, you might see this in physical science or chemistry. You might have a formula for force, but to know the force, you got to know the acceleration maybe. And acceleration would have its own formula. So you would find the acceleration using that formula. Once you got that answer, you would throw it into the formula for the force. Now, they do this the other way. We got a g of f of x, which is g of f of x. So for this one, we put the f of x into the g of x. Okay, so it's almost like order of operations. You start with the innermost parentheses and work your way out. So I would start with my f of x inside, get that one, and then work my way into the g of x equation. So it's sort of tricky to explain it, but watch me do this problem here. F of x is going to equal negative 3x minus 1. G of x is going to equal x squared plus 3. They want me to find f of g of 6. So basically, this would be like f of g of a 6. So if you start with the innermost, you got to start with the g of 6. So I'm going to start with g of 6. All right, y'all, so here's the thing. To find g of 6, I got to take the g equation and put a 6 in for the x so that I get a 6 squared plus 3. So y'all with me? I'm taking the g equation and I'm putting that 6 into it first. So let's see what this equals. 6 times 6 is 36 plus 3. 36 plus 3 will give us 39. So now, this 39, we're going to put the 39 into the f of x equation because that's the answer we got. So that means I'm going to find f of 39. Right? I found g of 6, it equaled 39. Now I put the 39 into the f of x, so that'll give me negative 3 times 39 minus 1. All right, so let me see what that equals. Negative 3 times 39 equal to negative 117 minus 1. And negative 117 minus 1 is a negative 118. Final answer. So 6 goes into the G, you get that answer. Then you put that 39 into the F. These aren't too bad. They just a little different because not many people's ever messed with that F of G. All right, y'all, moving on. Oh, let's see what they got on this one. F of x is going to equal 3x plus 3. G of x is going to equal,
Sir,
yes, oh, okay, bring it up. I'm with you now. All right, so f of x is 3x plus 3. G of x is going to equal x squared minus 2x minus 3. They want us to find G of f of 6. So 6 is the popular number today, I guess. But remember, they reversed it. Remember, this is really G of f of 6. So I usually write it like this, and then I can follow my order of operations, which means I'm going to start with the f of 6. All right, that was an H there. So start with f of 6. F of 6 will equal this f equation, 3x plus 3. In place of that x, I'm going to put that 6. So 3 times 6 plus 3, which is 18 plus 3. 18 plus 3 is what, a 21. Which means this 21 goes into the g of x now. Which means you're finding me g of 21. Oh, that's going to be a big number, y'all, because look at that. 21 squared minus 2 times 21 minus 3. So these are almost like two problems in one because they're making you find that f. And then once you find the f, they're making you find the g. So y'all, woo, 21 times 21, that's a big number, I think. That's going to be 441 minus 2 times 21 is 42 minus the 3. So let's see, 441 minus 42 minus 3 is going to give me, what's that, 396. And 396 is final answer. All right, this one they want me to find f of g of x and g of f of x and the domain of each. So now I've got to find what f of g of x and g of f of x are, and then I got to find the domain of each of these. They're giving me f of x equals x plus 19. G of x is going to equal x minus 19. All right, so first we're going to play with the f of g of x. All right, which is really f of g of x. So you would start with the g of x. But y'all notice, they didn't give me no numbers to plug in, so g of x is going to stay x minus 19. So what's going to happen when you don't have a number to make this smaller? This whole thing goes into the f of x. So you're going to find f of x minus 19. So to find f of x minus 19, you take the f equation, x plus 19, and where they got that x, we got to put x minus 19. So plugging x minus 19 into the x gives me x minus 19, and at the end is still a plus 19. So y'all, let's see, the only thing you can do is add those like terms, because negative 19 and 19 cancel. So the final answer on this would be x. Now let's write the domain. And these they want in interval notation. So they want me to write my answers in interval notation. So here's the thing. There's no fractions on the g of x that I got to worry about. When I found my f here, there's no fractions on the f to worry about. So since I didn't have no fractions, this works for all real numbers. To write that in interval notation would be from negative infinity to a positive infinity. So this is how you write all real numbers in interval notation. Okay, so it goes from negative infinity to a positive infinity. Now, I got to do g of f of x. So let me move my paper a little bit, y'all. So now we're doing g of f of x. And I'm going to move before y'all tell me. So remember, this one will equal g of f of x. So the first we're going to start with, innermost is f of x. Now, f of x, they're not giving me a number to plug in, but they did tell me f of x equaled x plus 19. But y'all, since we cannot simplify this and add this together, all of this goes into the g of x now. So that means we're going to find g of x plus 19. So we take our g equation, which was x minus 19, replace its x with an x plus 19, and then at the end is still the minus 19. So you still got x minus 19, but notice, once again, those 19s cancel. So since they cancel, I end up with a x. So the domain. And once again, I'm going to write interval notation. I have no fractions here. I have no fractions here to worry about. So once again, the domain will be from negative infinity to a positive infinity. So if y'all notice, on those domains, I'm only worried about fractions. So I'm going to give y'all the granddaddy of all problems. I'm going to find f of g of x and g of f of x and the domain of each. Now watch this. F of x is now going to be, let's see what I got, 5 divided by 1 minus 6x. G of x is going to equal 1 over x. So let me say this. We definitely have fractions, so we're definitely going to be worried about these domains on this one, okay? So first, let's play with f of g of x, which means f of g of x. Basically, you start on the right and work your way left on these. So I'm going to start with g of x. Well, g of x they gave me was 1 over x, which means in a second I know that this x cannot equal 0 because I got to take the bottom and set it not equal to 0, and there's only one variable down there. So now, on this problem, since I cannot do anything with the 1 over x, this whole thing is now going into the f. So we're going to find f of 1 over x. So to find f of 1 over x, we take the f equation, 5 divided by 1 minus 6 times x. But remember, my x is now a 1 over x. So y'all, this problem is tedious to try to fix. But we're going to attempt it, okay? So, first thing to do to simplify this bottom, since that's a 6 and I got a fraction I'm going to multiply by, I'm simply just going to put a 1 under the 6 so that when I multiply that, I get my 5 on top. The bottom will be 1 minus, if I multiply this together, 6 times 1 is 6 on the top. 1 times x is an x on the bottom. So your next step is to rewrite the bottom as a single fraction. So I'm going to rewrite bottom as a single fraction. So let me ask you this. Off on the side, I'm going to do side work. My side work is taking this 1 minus 6 over x and writing that as a single fraction. So first, under the 1, treat it like it's a 1. And y'all, in order to combine this, I need a least common denominator. Least common denominator is a 1 on the bottom and an x, and 1 times x is just a x. So what you would do now is change this first fraction so that it has an x on the bottom. So here's the thing. if you multiply the bottom times the x, you got to multiply the top by the x. So at this point, you get x divided by x minus 6 divided by x. Now, since these both have the same thing on the bottom, I can now rewrite this as one fraction by putting the x on the bottom, and then everything else goes on the top, which is the x minus 6. So now this is a single fraction. So remember, you can combine two fractions into one, or I could have took the 1 and split it into 2, okay? So, notice what I got. I got my 5. This 1 minus 6 over x gave me a x minus 6 over x. So remember, I did side work and I put that there. Now, what I would do, we got to keep going. So remember, this is a 5 divided by x minus 6 over x. Can I not do this? Change that to multiplication. So I'm going to change from division to multiplication. But if you change from division to multiplication, you got to flip the bottom fraction so that you get an x over x minus 6. And then once again, I'll put a 1 under the 5. So remember, if you take a top number, treat it like a fraction. 5 over 1 divided by x minus 6 over x is the same as 5 times x over x minus 6. Last step is to multiply. 5 times x is 5x. 1 times x minus 6 is an x minus 6. This is now what we call a single fraction, and they're happy with that. So y'all been a while since y'all played with this kind of stuff. This is what we call complex fractions. Y'all should have messed with them a little bit in foundations, I think. But here's what we want for this. We want the domain of f of g of x. So notice right here, when I first started, I got a situation with an x under here. So I know at that point, x cannot equal 0. Take the bottom and set it not equal to 0. So I'm good there when I applied it, and I'm good here, still can't be a 0. I'm good here, still can't be a 0. But notice what happens. Once I get this broken down into multiplication, oh, let me let one in. And I got it flipped over. I now got to worry about this fraction because on bottom is x minus 6. So I know that x minus 6 on this cannot equal 0. So this one I don't have to work. This one I got to add 6 to both sides. And y'all, this one tells me x cannot equal a positive 6. So let me show you interval notation. Since you cannot have these numbers in here, watch this. You're going to start at negative infinity. Now the interval has to go left to right. So which of these numbers would I hit first? I would hit the 0 first. So from negative infinity, I go to 0. And y'all, what I'm going to do is what we call a union. You union around that 0. Anytime you use curvy parentheses on an interval, it means it does not include the number next to it. Now, had that been brackets, brackets mean it includes that number, okay? So what you do, you union around the 0, and then the next number you hit the 6. So you go from 0 to 6. You're going to union around that 6. And then from 6, you head towards positive infinity. So they're always going to have a negative infinity on the left side, positive infinity on the right side. Any numbers you kick out using them unions. So this is telling me, hey, you can start at negative infinity. You can go almost to the 0, but you can't equal 0. Then you can start on the other side of the 0 and go until you get almost to that 6. Then you start on the other side of the 6 and you head towards positive infinity. So y'all, that was my f of g in my domain. And let me show you. Here's how they put them on the answers. So you notice on that one, I had a 0 and a 6. So I would have had to use this one down here where they're going around the zeros and the 6s, okay? This one, somehow they got negative 6s. This one, they didn't even exclude the 0. And then that one, they didn't exclude the 6. So you'll see answer choices for what you need on those. Now we got to do g of f of x. So I would start with my f of x. Now,
Yeah.
f of x, whoops. There we go, that better. So I would start with my f of x on this one, and f of x was 5 divided by 1 minus 6x. So I will be worried in a second because that 1 minus 6x cannot equal 0. But what's happening, since I can't do nothing with this, all of this will now go into the g. So we're going to find g of a 5 divided by 1 minus 6x. So remember, the g was 1 over x, which will be 1 over. So my x is now a 5 divided by 1 minus 6x. So notice, at the moment, I'm still worried about that 1 minus 6x because it's on the bottom of my fraction. So y'all, since this is basically one fraction on the bottom, I'm going to take that 1, change it from division to multiplication. And when I do that, I got to flip it. So I get 1 minus 6x over the 5. So I always take these and change them out of division into multiplication. You just got to make sure you got one single fraction on the bottom to do that, okay? All right, treat the 1 like it's got a 1 on it. Multiplying straight across, you get 1 minus 6x over 5. If you notice on this one, the only thing that's ever on bottom that bugs me is 1 minus 6x. That 5, since it don't have a variable, we don't care about that, okay? So to find the domain, on this one, we know 1 minus 6x cannot equal 0. All right, then we would solve this. So 2 ways to solve it. What I'm going to do, I'm just going to subtract 1. I get negative 6x cannot equal a negative 1. And then I'm going to divide both sides by the negative 6. So that I get x cannot equal a negative divided by negative makes that a positive 1 over 6. So notice I've only got one number to kick out of my domain. So my domain is going to start at negative infinity. I'm cruising on that until I hit this number I'm going to exclude, which is a 1/6. So I union around that 1/6. And then from the 1/6, I head towards positive infinity. All right, and that'd be the final answer on that one. All right, gotta get my notes back up. All righty, so what we're going to do, let's take a 10-minute break. I'm going to come back and I'm done with the college algebra lectures. That takes us all the way through 9.1. So I'll cancel this video, and what we'll do in 10 minutes, if you need support help, we'll knock out support.